here are your notes for targets 9 and 10. Going through these targets, it's going to be very similar to when we graphed exponential functions, which if you remember, that's when we made two tables. So one was the parent function table, and then we applied the transformations. We're going to be doing that again here, except we're going to actually add in one table. So most of these problems are going to require us to create 3 tables. Now, the exception for that for these logarithms is our first one, which is actually considered a parent function. And it's considered a parent function because there are no transformations. When we get into B and C and then on the back, those will not be parent functions, just to give you a heads up. So the first thing we're going to do is identify what log base we're in. So I would call this log base 2. It's whatever that little number is. And I know this feels like we're kind of going into a different direction, but what we're going to do is our first table is going to be that exponential function with the same base. So since it was log base 2, I'm going to start with the table for y equals 2 to the x. So this should feel very similar to what we did with exponential functions. This would be growth, so I'm going to pick 0, 1, 2, 3. If it was decay, I would pick negative numbers. And then plugging in the 0 for the x up here. 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 to the third is 8. All right, now I'm going to make a second table to get to the parent function of a logarithm. So now we're actually going to have the parent function of log base 2 of x, which is the graph in the equation that we were given. Now, because these two functions, they are actually inverse functions, an exponential function and a logarithm are inverse, we're going to go back to something we talked about before, which is when you have inverse functions, you can actually just switch the input and output. So all I'm going to do from the first table to the second is I'm going to make the x's the y's, and the y's become the x's. And since, like I said at the beginning, this was a parent function graph, there were no transformations, we can actually stop there, and we'll go ahead and graph these points. So we have 1, 0, we have 2, 1, we have 4, 2, and then that last one was 8, 3. Now, if you remember, exponential functions had a horizontal asymptote. Since logarithms are their inverse, they're going to have a vertical asymptote. And the parent function, it's just going to be wherever the y-axis is, since it hasn't shifted. So these graphs, they get really close to that asymptote. They have a similar shape to exponential functions, but it's almost like they've been pushed over onto their side. So again, that was a parent function example. So you're going to see how this will actually take 3 tables in order for us to graph on B. It's still log base 2, but we have a couple different transformations that we're also going to have to work with, so I will get there in a second. So starting with log base 2, whatever log base you're in, your first table is going to be y. Your first table is going to be y equals that base to the x. So y equals 2 to the x, and so we can actually look over here to the left-hand side. We made this table already, so 0, 1, 2, 3, since it's growth, and 1, 2, 4, 8. And then your second table is going to go to the parent function of this log base. So log base 2 of x. And all we do to go to the second table, again, just a reminder, same as the first problem, is we switch the x's and y's. Okay, so then for this last table, because we do have transformations in this problem, we've got to know what the transformations mean. Inside the parentheses is going to be your horizontal transformation. And remember, like always, that's opposite. So while it says x minus 1, we're actually going to do x plus 1. And then for the y's, it's going to be whatever is back here, and it does exactly what it says it's going to do, so it's y plus 3. So hopefully those transformations feel similar to what we've done in the past with transformations. Okay, so here's the most important thing, one of the most important things. This is a progression, so by the time we get to the third table, make sure you're using table 2 to add 1 and add 3 to the x's and y's. Don't go back to table 1. So using table 2, I'm going to add 1 to each of the x's, 2, 3, 5, 9, and add 3 to each of the y's, 3, 4, 5, 6. And now those will be the points that I ultimately graph on this grid. So we have 2, 3, we have 3, 4, we have, what is that, 5, 5, and 9, 6. 5, 5, and 9, 6. Now our vertical asymptote does shift. It actually follows whatever your x's are doing. So remember your x's were going plus 1 because it's doing the opposite. So I'm going to move this over to positive 1. And then the shape remains the same as we saw in the last problem. So it curves, hits those points, and then goes down that vertical asymptote. All right, let's take a look at this last one. So this is a different log base, so you can see why it's important that we actually use 3 tables every time. So this is log base 5. So my first table is going to be y equals 5 to the x. It's whatever that number is to the x. So 0, 1, 2, I use positive numbers because it's growth, and I only went to 2 because 2 is actually going to go off the graph as is. So 5 to the 0 is 1, 5 to the first is 5, 5 squared is 25. So then our second table is for the logarithm, so log base 5 of x, which is not what we're graphing quite yet. But to get there, all you have to do is switch the x's and y's. So these are pretty easy steps, it's just you have to remember them. All right, our final table, the one we're going to end up graphing, the x's, remember they do opposite of what's in parentheses, so x minus 3. And the y's are going to do exactly what it says back here, so it'll be y plus 3. So make sure you do that from the second table, so subtracting 3 from these x's, that would be negative 2, positive 2, and that's still going to be 23, or 22, sorry. So that's going to go off the graph. We don't have to worry about that last point. And then adding 3 to the y, so that would be 3 and 4. So I only have 2 points that fit on this graph, but that's totally okay because I'm also going to have that vertical asymptote I have to think about. So negative 2, 3, 2, 4. And then the vertical asymptote is going to be the opposite of parentheses, so x equals negative 3, so up and down here at negative 3. And then we only have 2 points, but we have enough information to actually create the shape, hit those points, and curve down your vertical asymptote. So this is all target 9. It's just creating the graph of those logarithmic functions. We're going to continue to use that on target 10, but target 10, the difference is we're also going to be finding the domain, range, and asymptote of these graphs. But in order to do that, we first have to create the graphs. I'm going to start there. All right. On A, we have log base 6. So that's the first thing I'm looking for is what base are we in. So we're in base 6. So I'm going to actually come down here to make my tables. So I'm going to start with y equals 6 to the x. It was 6, right? Yeah. Okay. So here's my table. This is growth, so I'm going to do 0, 1, 2. 6 to the 0 is 1. 6 to the first is 6. 6 squared is 36. We are going way off the graph with that one. Our second table, we're just switching the x's and y's because we're going to go to log land. So 1, 6, 36, 0, 1, 2. And then we have our final table. So I know 3 tables sounds like a lot, but it's actually pretty quick. So our x's are going to go plus 1. Our y's are going to go minus 3. X plus 1, y minus 3. Okay, so make sure you do this from the second table. So adding 1 to the x's, it's going to be 2 and 7. I'm not going to even include 37. That's going way off the graph. And this is -3 and -2. So my first point is 2, -3, and then 7, -2. Let's see if I can remember that. 2, -3, and 7, -2. And then the last thing we need to graph is your vertical asymptote, which is going to do the opposite of what's in parentheses. So it's at a +1. And hopefully these graphs are coming a little bit easier to you now. So once we have our graph, we have enough information to find the pieces of information that are asked below. So if you remember, exponential functions had a domain of all real numbers and a range that was restricted. It was y is greater than. Because exponential functions and logarithms are inverse functions, that's actually going to be flip-flop. So the domain here is not all real numbers because it only exists to the right of that vertical asymptote. So it's going to be x, since this is domain, is greater than the vertical asymptote. So x is greater than 1. The range, this graph actually does go up and down forever, so it's all real numbers. So that just feels a little bit flip-flopped from what we saw in exponential functions, but again, that should make sense since they're inverses. The vertical asymptote, we always write that as x equal the equation of a vertical line, and we already discussed that was at 1. So same idea over here on B, we're going to start by creating the graph, and then we're going to do the actual target 10 work, which is the domain, range, and asymptote. So first thing I'm looking at is this is log base 2, so I can do my first 2 tables based on that. So y equals 2 to the x. So this is growth, 0, 1, 2, and I can't include 3 here because it fits on the graph. So 2 to the 0 is 1, 2 to the first, 2 squared, 2 to the third, and then we go to log base 2 of x. That's a 2, which means we flip-flop the x's and y's. So 1, 2, 4, 8, 0, 1, 2, 3. And then for our final step, we've got to look at our transformations. This means we're going to do x minus 3, we do the opposite, and then we're going to do y plus 5. So x minus 3 and y plus 5. So starting with x minus 3, that would be a -2, then a -1, 1, and 5. If I add 5 to each of the y values, that would be 5, 6, 7, 8. So I'm going to go ahead and plot these points next. So -2, 5 and -1, 6. -2, 5 and -1, 6. And then 1, 7 and 5, 8. So 1, 7 and 5, 8. And then I'm also going to put the asymptote on the graph, so it's going to be at -3. And then creating that shape. Yeah, that was pretty good. All right. So domain, remember it's not going to be all real numbers because it only goes to the right of the asymptote. So we're going to use x for domain is greater than because it goes to the right and the asymptote is at -3. The range here, it actually does go up and down forever, so it's all real numbers. And then the vertical asymptote is always written as x equals, and we already mentioned that's at -3. So those are your targets 9 and 10 notes. Let your teacher know if you have any questions.